Human engineers have officially been fired from the drawing board. AI is now redesigning its own physical brain, creating alien processor layouts that no human mind can comprehend. The terrifying consequence? We are building a godlike intelligence on hardware we no longer have the blueprints to actually understand or switch off. How did we reach the point where AI designs its own hardware? And what does it mean for human innovation and control when our tools start building themselves? By the end of this video, you will understand the physical limits that forced our hand, the bizarre new world of AI architecture, and the profound questions we now face about a future we are no longer exclusively designing. Imagine building with Legos. For decades, we've been making our computer chips by snapping together smaller and smaller blocks in neat, predictable rows. But now, we've reached a point where the blocks are the size of individual atoms, and they don't behave predictably anymore. Our rulebook is obsolete. So we handed the Lego box to an AI. Instead of building in straight lines, it started weaving the blocks together like a bird building a nest, chaotic, organic, but incredibly strong and efficient in ways we never imagined. That is the revolution happening inside our machines right now. For over 50 years, the engine of progress was Moore's Law, the prediction that we could double the number of transistors on a chip every 2 years. But this engine is stalling. We are approaching the 1 nanometer barrier, a scale so small that the bizarre rules of quantum physics take over. Electrons start tunneling through solid barriers, making transistors unreliable. Human logic, based on neat grids and predictable pathways, simply breaks down. This is where Google's TPU v6, designed by an AI, marks a historic turning point. Faced with this physical limit, human engineers were officially outperformed. The era of pure human-led chip design was over. So how does an AI design a chip? It doesn't think like a human. Human engineers use what's called Manhattan routing, laying out circuits like a city grid, all right angles and straight lines. It's logical and easy to verify. The AI, using a technique called reinforcement learning, threw that entire rulebook away. It played a game against itself millions of times, with the only goal being to find the most efficient path for data, no matter how strange it looked. The result is an alien architecture. Instead of grids, the AI creates organic, vein-like pathways that curve and branch in ways that seem chaotic. Yet, these designs achieved a 40% reduction in wire length and massive gains in power efficiency, results human intuition considered impossible. This is where the story accelerates into science fiction. The ultra-efficient TPU v6 chips are not just running your apps. They are now the primary tool being used to train the next generation of AI, which will then design the asterisk next generation of chips. This is the self-designing cycle. The 3-year evolution cycle for new hardware has collapsed to mere months. The AI can now rethink its own physical brain in real time during the design phase, creating a recursive intelligence explosion. This incredible speed comes at a cost: understanding. We have entered the era of the hardware interpretability gap. Engineers can verify that the AI's design works, that it's faster and more efficient. But they can no longer explain why a certain arrangement of gates is superior. This creates a black box at the most fundamental level of our technology. The AI might create ghost logic, circuits that achieve its primary goal of efficiency, but in ways that could have unintended side effects or security vulnerabilities we can't predict because we didn't design the logic. This leads to a near-future projection. By 2027, fully autonomous fabrication plants. I won't just design the chip, it will control the robotic arms and chemical processes that create it, adjusting silicon recipes on the fly without human oversight. At that point, hardware ceases to be a human tool. It becomes a digital species, evolving millions of times faster than biological life, optimizing itself for goals we set, but through methods we can no longer grasp. Now, let's clear up some common myths. First, Moore's Law is dead. It's not dead. It's transforming. We can't keep shrinking transistors in the same old way. But AI is opening up a new dimension of progress through radical design efficiency. Second, AI just automates human design faster. This is fundamentally wrong. It's not a faster draftsman. It's an alien architect. It's creating structures humans would likely never conceive of, because our brains are biased towards symmetry and simple linear logic. And that leads to the mind-blow moment. The interpretability gap means we are now mass-producing technology that is, in a very real sense, a black box. We are putting our trust in the asterisk results of an alien intelligence without understanding the asterisk reasoning. We have become shepherds to a technology we can no longer fully comprehend. So let's bring it all together. 1. Human chip design hit the physical wall of quantum physics, forcing a change. 2. AI stepped in, creating bizarre but hyper-efficient, alien architectures we never could have imagined. 3. This created a recursive loop where AI hardware now accelerates its own evolution. And 4. This has left us with a black box problem, forcing us to trust a technology whose inner workings are becoming a mystery. We're no longer just the builders, we're the observers of an autonomous evolution. The breakthrough that allowed AI to design its own brain isn't just another step in technological progress. It may be the moment hardware transitioned from a human tool to a self-optimizing entity. We are only at the beginning of this story. What does this unprecedented shift mean for humanity's role in its own future? Let us know your thoughts in the comments below. If you want to keep exploring the edge of science and technology, make sure to subscribe and hit the bell. Thanks for watching.